In this demonstration, we build on the themes of GIS for visualization, planning, and analysis that you saw in the previous demos. This time we'll feature the collaboration, data sharing, and publication capabilities of ArcGIS Online. In the visualization demo you saw earlier, Todd showed you how to add data to an ArcGIS Online map viewer. In the map you see here, I've actually added map services from our EGIS platform that show the location of HUD-assisted properties, as well as HUD insured and owned properties. Beneath that, you'll see a layer representing the flood surge extent from Superstorm Sandy. This data was compiled from remotely sensed imagery and later published by FEMA not long after the storm hit. Registered users of HUD's ArcGIS Online can share this map within our agency, within a specific group in our agency, or with the general public. Additionally, this map can be embedded in a website with minimal effort. By simply copying this automatically generated snippet of code and sending it to my webmaster, it can easily be integrated into a website such as this one. And this is an example of how these capabilities foster increased data sharing and collaboration between agencies. It allows program staff as well as senior leadership to quickly visualize the potential exposure of HUD's interests in a post-disaster situation. Continuing with the Sandy theme, I'm going to build upon some of the other concepts that we touched on in the earlier demonstrations. In this example, I'm going to show you how we use geocoding along with the analytical capabilities of ArcGIS Desktop and the publishing capabilities of ArcGIS Online to allow HUD grantees and program staff to identify the communities and neighborhoods most affected by Superstorm Sandy. After a presidentially declared disaster, FEMA conducts housing inspections to determine eligibility for FEMA individual assistance applicants. Through a data sharing agreement with FEMA, PD&R receives these inspection data at the individual address level. These are the points you're seeing drawing on the map right now. These data are a critical component of HUD's disaster recovery grant allocation process, but due to privacy concerns, they cannot be released to the public in this form. By geocoding the data, HUD is able to locate each individual address and assign each inspection record to a specific political jurisdiction or census tract and block group. This allows the GIS analyst to summarize the inspection data by jurisdiction or by neighborhood and identify areas where the storm impact was most severe. Summarizing the data to a specific census geographic level, such as block group, also allows the analyst to cross-tabulate the inspection data with demographic and socioeconomic characteristics of the neighborhood, giving planners and decision makers insight into which communities will require the most assistance in their planning recovery efforts. The map you are looking at now shows individual inspection data that has been aggregated to the census block group level. The areas in darker red indicate the highest concentration of damage. Superstorm Sandy was primarily a flooding event, so FEMA inspectors gathered data on the height of flooding. They indicated the highest floor of flooding, for example, whether it was the basement, first floor, second floor, etc., and the height of flooding in that room. Other useful information included the number of registrants that had insurance versus those that didn't, and their tenure, whether they owned or rented the house. This is all very useful information, but how do we get it off the analyst's desktop and into the hands of planners and decision makers more quickly? HUD employees who have publishing rights in our ArcGIS Online subscription can publish this map and all the underlying data in it right from their desktop into the ArcGIS Online environment. After specifying a few parameters, this map document will be automatically uploaded into the hosted environment and a service will be created. I just have to go ahead and specify a name for it, followed by some other essential parameters. There will be training on this later, so I'm not going to go over the details of it right now. I will point out that the description of the map and the data in it has already been filled out in the map document, and this will persist all the way through to the map service that's published from it. And finally, you'll be able to determine who has access to the service, whether it's members of individual groups within the organization as a whole, or the general public. Now I've logged back into ArcGIS Online, and I'm going to go ahead and do a search for FEMA. And what should come back are all the results that match that keyword, one of which includes the map service that we just published, which is right here. I can open it to view the details. You can see a description of the map service here. You have the choice to open it in ArcGIS.com map viewer or even in the desktop tool. You also have the ability, if you're a named user, to download the data as a shapefile or in raw text format in a comma delimited text file. This is a web map that I created with the feature service that we just published. I've configured a pop-up to include all the information on damaged units. This is the same information that was in the data that we published. And in addition to that, I've also configured a few charts in the pop-up. This one shows the number of damaged units by depth of flood. So if I mouse over that, I can see that in this particular neighborhood, the majority of damaged units had the basement flooding of up to 2 feet or more. There's also a chart that shows damage by insurance status, so you can see of all the owner-occupied structures that in this particular neighborhood, over half of them had insurance. And this is another useful chart which shows damage by building type, so you can see that the majority of homes damaged in this neighborhood were single family. Now, I demonstrated earlier how the web map can be shared either as a direct link in an email or via social networking sites, but you can also publish a simple web mapping application using the web map. There are a variety of templates that you can choose from. I'm going to go ahead and show you what the basic viewer looks like. So here's a simple web application that we created without any web programming skills whatsoever. You can see that there's a title for it, which comes from the feature service name. There are details, which also comes from the feature service that we published. Tells the user a little bit about what data they're looking at, where it came from. There's also a legend associated with the map. And just as in the web map, you can click on an individual block group and get information about the damage in that area, as well as view the pop-up charts that I showed you earlier. As with any interactive map, users can pan and zoom, or use the search box to type in another place name or locale to zoom to. I'll type in Atlantic City so we can see what the damage looks like there. Just like the web map, the application can also be easily embedded in your organization's website. This is just one example of how GIS can foster increased data sharing and collaboration between agencies. With these capabilities, HUD can quickly and efficiently make critical data analysis available to our grantees in support of their long-term recovery planning efforts. The potential also exists for HUD staff as well as the Inspector General to leverage these same data and tools to monitor recovery grants.